All right, let's go ahead and take a look at ions. So for ions, the basic idea is we have two rules. We have the octet rule and we have the duet rule. So the octet rule basically says the number of outside electrons or valence electrons needs to be 8. So atoms are going to gain or lose to get 8 electrons on the outside. The exception is the first 6 elements can have 2. So if we look at elements 1 through 6, it can be full, meaning the first ring can only hold 2, every other ring can hold 8. So that's where we get our two rules for this. So the octet rule, we can go ahead and look at an example of this. So for here, we have chlorine. Chlorine wants to get 8 electrons. Right now, it has 1, 2, 3, 4, 5, 6, 7. 7 valence electrons. So in order for it to get 8, it's going to have to gain 1. So if it gains 1 electron, we add an electron to the missing piece. So we see that here there was a missing spot. We're basically filling in the gaps. So we have 8. All right. So that's the simplest way. So all of the non-metals, chlorine's a non-metal because it's on the right-hand side of the periodic table, are going to gain electrons. Okay, metals are a little bit different though. So if we look at the metals, we look at sodium. Sodium has 1 valence electron, 1 electron on the outside. It needs to get to 8. So that's two options. It can gain 7. We can add 1, 2, 3, 4, 5, 6, 7. We could add 7 electrons to this, but that's a lot of electrons to pick up. So there's an easier option. Um, Give the analogy, it's like peeling off a layer of an onion. So if you have kind of a bad layer on the top, you have a fresh layer underneath. So if we cover this, we can see we have 8 that are underneath this. Because when we talk about valence electrons, we're not saying it has to be this outer energy level, this outer ring. It could be the one beneath it. We just need to have 8 total. So what we're going to do is we're just basically removing this electron. So if we lose 1 electron, what we get is this sodium here that has the 8 that are beneath. So what we would end up doing is we lose and get 8. And so this is where it gets a little bit weird. And this makes sense. We have 7, we add 1, we get 8. But here we have 1 and we subtract 1 and get 8. So we're just subtracting the outer layer. All right. So we can look at an example of this. This whole table here, we're just summarizing what's in the notes. The one thing to note for ionization energy and electronegativity is if we look at electronegativity and ionization energy, they give us them here. So we say metals have a low ionization energy, nonmetals have a high electronegativity. So these are going to be opposite trends. So for metals, this is going to have a low ionization energy, and for nonmetals, this is going to be a high electronegativity. When we look at what these mean, ionization energy is the energy needed to pull an electron off. Electronegativity is the energy needed to take an electron in. So we're looking at how electrons are being removed or added. So there's low energy for this, so it's easy to remove. There's high electronegativity, meaning it's easy to gain or add. So these are going to be opposite. So high electronegativity means, um, sorry, here we have, no, no, both these are good. First recording, so we're fine. So both these are going to be the same trend. So we want to fill this in to make sure that we got this correct. All right, let's go and look at a few of the Bohr models. So we'll get an example going for us. So let's look at calcium. Calcium, we're going to draw our nucleus for the Bohr model. We're going to find the element. So calcium, element 20, has 20 electrons. So for calcium, we're going to have 20 electrons. So let's fill this in. Our first energy level can only hold 2, so 1, 2. And then we're going to keep adding. Next one could hold 8, 3, 4, 5, 6, 7, 8, 9, 10. So we're at 10. We're going to add another level. So 12, 14, 16, 18. So we're at 18. We need to get to 20, and then we'll add one more. So we should get one right now. So if we look at calcium, the number of valence electrons calcium has is 2. 1, 2. So it needs a total of 8. This is going to be our octet rule. So for this to work, we need to get 8 electrons. So for us to get 8, we have two options. We can add 6 to the outer ring, or we can remove 2. Since calcium is a metal, we're going to lose electrons. So metals lose. So we're going to take these two outside electrons away, and what our Bohr model for the ion is going to look like is this. So it's going to be the same as before. So we'll fill in our 3 rings. So we have 2, 4, 6, 8, 10, 12, 14, 16, 17, 18. So we had 20 electrons. We lost 2, so we get 18. So if we check, we have our 8 here, 2, 4, 6, 8. And we're going to just put parentheses around this to show that this has a charge. And the charge is going to be 2 plus, because it lost 2 electrons. All right, let's go and look at chlorine. Chlorine is going to be element number 17 on our periodic table. So chlorine is here. So element 17. So we're going to fill in our electrons. We have 17 electrons. So this is going to look similar as before. So 1, 2, 8 in the next one is 10. And then the third ring, we have 7. 1, 2, 3, 4, 5, 6, 7. So we have 7 electrons on the outside. 1, 2, 3, 4, 5, 6, 7. And we can see that we're missing a piece here. So we need to add 1 electron. This wants a total of 8. So we're going to add 1 electron here. So if we look at our ion, it's going to be filling in this missing piece. So we are going to gain 1 electron. So our nonmetals gain. So to get this, we're going to add 1 electron. So our Bohr model should be the same. Our completed row here. So I'm basically adding this electron that was missing is now going to be added. Since this gained 1 electron, we're going to say that this is minus 1. Because this lost 2, this gained 1. All right, let's go and look at the last one. Beryllium is going to be different because beryllium is one of the lower elements. Beryllium is element number 4. So on our periodic table, beryllium is going to be element number 4. So we're going to have 4 electrons. So thankfully this is a little bit easier to draw. Okay, so this is what beryllium is going to look like. Beryllium has 2 valence electrons. We know that this is a metal. So beryllium is a metal because it's on our left-hand side. This is an alkali, earth metals. So this is going to be a metal. Our metals lose. So our goal is to get a full ring on the outside. So a full energy level. We had a full energy level here. We had a full energy level here. If we want a full energy level, we can add 6 to this outer ring, or since it's a metal, we're going to lose the outer rings. So here, this needs to have 2 valence electrons in the outer one. It wants a full shell. So here, we're going to peel this back layer away. So the total electrons it needs 2 in the first energy level. So we're going to lose these two here and peel them away. So if we lose these two, this one's full. So 2 in the second is not full. Here we have a full energy level. So the first ring can hold 2. So that's why we're losing 2 to get a full ring on the outside. And then the last bit that we're going to do, we're going to put this in brackets. This lost, so it lost these 2. So we're going to say it's plus 2 because it lost it. All right, and that's the basic idea for these Bohr models. The rest of this, we're just kind of filling these in. So our goal for each of these is just to look at our periodic table, find the number of valence electrons, and fill them in here. So going through all of these, we can look at our periodic table and we're going to notice a trend. We're going to write our atomic number, our metal, non-metal, metalloids, so we can look at our labeled periodic table, number of valence electrons, our group number, total electrons, and then our number lost. So we should be able to fill these in. So if we're looking at helium, He, helium is going to be element 2, so atomic number 2. Helium is on the right-hand side, so this is going to be our non-metal. All right, for valence electrons, how many electrons does helium have on the outside? Helium is going to have a total of 2 valence electrons. Because if we were to draw this out, helium would look something like this. Helium would have only 2 electrons. So those 2 are our valence electrons. So 2 valence electrons. If we look at our group number is going to be 18. And then we just fill in the rest of these. Our first 6 elements, all of these need 2 electrons. So the duet rule says first 6 elements need 2 valence electrons. So our goal is to figure out what's going on with this. All right, well, helium has those 2 valence electrons. If we look at helium here, so some of these, when we're looking at number lost or gained, helium is fine, it's full. It doesn't need this, so we're going to say it's neither. So there's neither. So if we look at the ion, it doesn't form an ion. So this is just going to be regular helium. All right. We can just keep doing the same for the rest of these. If we're looking at element 3, lithium. Lithium here, we have 3 electrons. We're going to call this our metal, because lithium's on the left-hand side of the periodic table. If we look at our number of valence electrons for these, our lithium is going to have a total of 3, because lithium, we're basically adding electrons to this. So lithium, we're going to have a total of 3 electrons. So it's going to have 1 valence electron on the outside. So that's going to be our 1 valence electron. Lithium is going to be in group 1. It needs 2, so it's a metal, it's going to gain 1. So we end up getting Li+. We're going to continue as we're going through these. So one of the tricks for these, if we're looking at valence electrons, you're going to start to see a pattern. The number of valence electrons is going to be equal to the number along the top. And that's something that we'll get down to. So our valence electrons, we're just circling these numbers here. So group 1 has 1 valence electron, all of these. Group 2 has 2, group 3 has 3, group 4 has 4, group 5 has 5, 6, 7, and 8. So when we're looking at these, we can just get rid of the 1 to find our valence electrons. So we can say that these are valence. One exception, helium. Helium can't have 8 because it only has 2 electrons. So helium is a full shell, but has less than that. All right, so you should be able to fill this in. On the back is just summarizing the patterns for it.